Welcome to class 11th and 12th math. Today we'll learn the vectors chapter. This is unit 10 from the NCERT. As you see, I have just covered first two chapters from the NCERT, and then after 1 and 2, 1, 2 and 3, I'm jumping to 10th chapter. Okay, this is actually comes in 12th class, not even in 11th from the NCERT syllabus. But I feel this is very important chapter because in class 11th, in the initially whatever physics your problems you solve, this vector chapters will help you a lot actually, and you will be learning basics of vectors as part of physics also. Okay, so I feel this chapter is important to learn before. So let's do vectors chapters first. Okay, this is good for class 11th, 12th, and the JEE bits at engineering entrance aspirants. What we will learn in this is definitions of the vectors. What are the various kind of vectors? Position vector, zero vector, unit vector, collinear, etc. Direction cosines, vector addition, scalar multiplication, vector product, vector components, then section formula, Cauchy's squares inequality for vectors, then all the NCERT exercises which are there. Okay, I am not covering the critical JEE questions in this video. This video has become already like over time. So I will definitely make next videos where I will cover the important JEE critical questions as well as I'll start making the shorts for a simple questions. Okay, shorts are already there. You can start solving those problems. Okay, let's get into the vectors. What is the definition of vector? Okay, vector is a quantity which has both magnitude and direction. Okay, this is the first definition of simple and first definition of a vector. Vector will have not only magnitude, it also has a direction. Okay, if I am walking towards east, then you can say that this is a vector quantity. Okay, if you are just walking, then you cannot tell that it's a vector. Okay, as simple as that. Okay, for a vector, if you are calling something as a vector, then it should be associated with some direction. That is most important. Okay, a vector is a quantity that has both magnitude and direction. Okay, the magnitude in the representation, if you are representing, let's say, with the two arrows, the size of the arrow represents the magnitude of the vector. Okay, the point A from where the vector starts is called initial point. Okay, that is the tail, right? This is the initial point. Okay, and the point B where it ends is called a terminal point. Okay, this is terminal point. Okay, so vector has initial point and a terminal point represented by AB arrow or A arrow, small a arrow. Okay, if you are representing using two positions, that is AB arrow. If you are representing using a single vector, then it's A arrow. The arrow indicates the direction of the vector. That means if you say AB arrow, then the vector is from A to B. Okay, from A to B. Okay, now example of vectors. Suppose if you take the first one, AB here, A to B vector is A to B, and here vector is from B to A. So you will call this BA. BA arrow. Okay, this is arrow, not just bar. Okay, there are different kinds of vectors. One most important thing and basic one is position vector. Position vector is nothing but it symbolizes either a position or the location of any given point with respect to an arbitrary reference like origin. Okay, which means if you take a three-dimensional graph, okay, three-dimensional space which has x-axis, y-axis, and z-axis, right? If you take any random point, it has three coordinates x, y, and z, right? So this is a position vector. By mentioning those x, y, and z coordinates, you are actually calling that a position vector. Means with those points, you can always, if you position that in the xyz plane, it will always be placed at the particular position, right? It is unique. So it's a position vector. It exactly tells where to put. Okay. So something like this. Okay. Origin is 0, comma 0, comma 0, and P is, let's say, x, y, z. Okay. Then this is R bar is the resultant vector. Okay. It has coordinates x, y, z. Okay. So if I tell x, y, z, I can always place at the correct position, and it is the unique position where I keep. Okay. So magnitude of OP, here O is the initial point, terminal point. P is terminal point. So OP bar, magnitude of this is, since the other point is 0, okay, x minus 0 square, square root of x minus 0 square, y minus 0 square, z minus 0 square, okay, sum of all three. That is square root of x square plus y square plus z square. So let's say I give you two positions, x1, y1, z1 and x2, y2, z2. Then magnitude of that one is square root of x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. Okay. You would have learnt already this one in the coordinate geometry, two-dimensional coordinate geometry in your 10th class. Just extend it to three-dimensional. Okay. Next. Some definitions of important vectors. Zero vector or null vector we call it. Okay. A vector with zero magnitude but certain direction. Okay. There is only direction but there is no magnitude. Okay. Then you call this a zero or null vector. Unit vector. Okay. From the name you can easily understand unit means 1. That means its magnitude is 1. Right. A vector whose magnitude is unity or 1 unit is called unit vector. Okay. And it is represented by not by arrow. We represent with a hat. We call it a hat. A hat. Okay, a hat is unit vector. Anytime you see hat, it's a unit vector. Okay, conditional vectors. Sorry, co-initial vectors. Co-initial vector is vectors whose initial points are same. Okay, whose initial points are same. Two or more vectors having the same initial point are called co-initial vectors. Okay, so example, this is co-initial vector, right? It has same initial point. These two are co-initial vectors. Okay, next. Types of vectors. Okay, still continue. Collinear vectors. Collinear, you know, collinear means they are in the same line, correct? So in case of vectors, they need not be in the same line, but they can be parallel also. Okay, even parallel vectors, you can call them collinear. Okay, two or more vectors parallel to the same line, irrespective of their magnitudes and directions, are called collinear vectors. Okay, magnitude is not important, direction also not important. Okay, so remember that. So if ai plus bj plus ck, okay, you might be wondering what is this ijk. Okay, a is x coordinate and I am telling this is x coordinate. Okay, b is y coordinate, j with the j I am telling this is j coordinate. Okay, these are all unit vectors in x coordinate, unit vector of y. Okay, y axis, unit vector of z axis ck, and xi plus yj plus zk are collinear vectors. Then their ratios are same basically. Okay, a by x is equal to b by y equal to c by z. Okay, and if you once you learn the scalar product, you will understand one is just a scalar multiplication of other one. Okay, equal vectors, two vectors having same magnitude and direction. This is most important. Two vectors are called equal if and only if their directions as well as magnitude are same. Okay, regardless of the positions of their initial points. Okay, so they can be a parallel vectors. Okay, different initial positions, but their magnitude is same and their direction is same. Okay, next. Negative vectors. Negative vectors is vectors whose magnitude is same, but they are in the opposite direction. They are the negative vectors. So here, what is this one? Okay, they are collinear, right? They are collinear, different magnitude, but they are in the same direction. They are parallel to each other. Okay. So here you call this one A bar equal vectors. These two are equal vectors. A bar is equal to B bar, right? These are equal vectors. These are all negative vectors, these two. This is small a bar and this is b bar, which is nothing but equal to minus a bar. Okay, opposite direction you can always represent with minus. Okay, next. Okay, direction cosines. This is very important to understand. This is the most useful thing for your physics when you do your mechanics, actually kinetics and mechanics, where when you apply angle to the force applied or the momentum applied angle to that one, then the cosine components will come, x component, y component, how they come. This you have to understand this. Okay, direction cosines are cosines of the angles that a vector makes with coordinate axis, which means very simple. We learned position vector is in the xyz plane, right? In three-dimensional plane. Okay, you have position vector and you have two position vectors. You draw a line between them. You call it a vector in three-dimensional space. Correct? Now this vector makes an angle with x-axis, y-axis and z-axis, right? Correct? If it is, let's say if it is parallel to x-axis, then angle with x-axis is 0. It has an angle, okay? It may be 0, but it has an angle, correct? So now these angles, if you take and then cosines of that, okay? Trigonometric cosines, you know, right? Cosines of that are called the cosines of the direction cosines of the vector, okay? So if this is the angles alpha, beta, gamma, it makes with x-axis, y-axis and z-axis, okay? Then the cosines L, M and N, if they are element, they are defined as L equal to cos alpha, M equal to cos beta, N equal to cos gamma. Alright. These are the directional cosines of the vector. Now, what is the important? I mean, how I can derive a component of x-axis, y-axis from this? That is simple. Okay. Now, cos alpha, cos beta, cos gamma are called direction cosines of the vector r bar, which is okay. The numbers L are, if you take L into r, M into R, N into R, which are proportional to the direction cosines. L, M, N are called direction ratios. Okay, direction ratios of the vector R. These direction ratios are denoted by A, B, C. Okay, A, B, C, and A, B, C are what? Nothing but A equal to LR, B equal to MR, C equal to NR. Okay, so this is nothing but, if you see, L is nothing but comes from the cos alpha. Correct, x-axis, right? So this is the x component of the vector. If r bar is the vector, this is the x component. This is the, if r bar is a force, let's say, then A is the force applied in x-axis direction, in the direction of x-axis. Okay, and B is the force applied in the direction of y-axis. C is the force applied in the z direction of the axis. Okay, in the direction of z-axis, basically. Okay, so with this, what happens? Let's say I'm calculating how much a object is moved when a force is applied in x direction. Okay, then I will calculate the angle it makes with the x-axis and then apply the resultant vector into cosine. Correct. So if it is x-axis, I need a equal to lr, right? And lr is the force applied in x-axis direction. So for the moment in x-axis direction, in x direction, I will always take the force as a, because this is what makes the uh, movement in the x direction. Okay, now you understand from where this is useful. Application of vectors is the mainly physics, that especially where you find the vector quantities. Okay, hope you understand this part. This is simple. We'll go more deep and understand the relations of cos and I, J, K, all that. Then it will be very simple. Okay, this is just a basic. So simple thing you have to understand is, what is the direction cosine? Angle made vector. The angles makes with x, y, and z axis. They are the direction cosines. Okay, and direction ratios are nothing but that cos alpha, cos beta, cos gamma multiplied with the resultant vector. Okay, then you will get three forces in the three vectors in the x, y, z direction. They are the direction ratios. Okay, one thing you need to understand is the cosines satisfy the equation L square plus M square plus N square equal to 1. Okay, cos alpha square, cos beta square, and cos gamma square equal to 1. Okay, so now let's go next. Let's do NCERT exercise 10.1. I'll not go through all the questions in detail, okay, which are straightforward, simple. You can solve it yourself. And first thing is, yeah, before looking at this video, first solve all the problems yourself and then check for any explanation if there is some trick or something is in the videos. Okay, first you have to solve it yourself. Okay, if you don't understand, yeah, you can then watch the video. Okay, represent graphically a displacement of 40 kilometers, 30 degrees east of the north. Okay, so this is just a positional vector. So you are in a xy plane, correct? And then you have to just show it a display in OP, a vector 30 degrees from east of north. Okay, so that means from north it is 30 degrees towards east. Okay, this is where it is, right? And how do you represent 40 kilometers magnitude? 40 kilometers is the magnitude, right? 40 kilometers magnitude I am representing using four equal bars here. and then mentioning in a scale saying that each bar is 10 kilometers. So 4 parts I have 40 kilometers. Okay, hope you understand this. Okay, classify these things. 10 kgs is a mass, so it's a scalar. 2 meters northwest. Okay, clearly there is 2 meters magnitude is there, northwest direction is there, so it's a displacement vector. 40 degrees is just an angle, so it's a scalar. 40 watt, it's just a power. Okay, so it's a scalar. 10 to 19 coulomb, it's a charge, it's a scalar. 20 meters per second square, this is acceleration actually. Okay, sorry, I mentioned it as speed, but this is acceleration, this is vector. Okay, acceleration is always vector. Okay, so this is wrong. I'll just mention it here. It's a vector. Okay, it's acceleration actually. Yeah, next. Okay, I can classify these things. Time period is a scalar, distance is a scalar, force is a vector, velocity is a vector, work done is a scalar. Okay, always differentiate between speed and velocity. Okay, speed is a scalar, velocity is a vector. Okay, these are all, if you see, these are all your physics terminology, right? So this is where your vectors actually is very helpful when you learn your 11th class physics, that to beginning mechanics. Uh, that is the main reason I choose vectors chapters first actually. Because once you are good in this mechanics, these things in physics, this will help you a lot in circular motion and everywhere actually, once you are good in vectors. Okay, so I think I don't know why in NCERT it is kept in second year 10th chapter. But if I see Telangana intermediate or 11th class syllabus, it is actually in the 11th class, I think third or fourth chapter in the beginning only. Okay, next. This is a square and things are mentioned here, vectors. What are the co-initial vectors which will have same initial point? Okay, so if you see here, this point, there are two vectors here, right? Starting from here, A bar and D bar, correct? Are co-initial vectors. Then equal vectors are D bar and B bar. If you see, they are parallel and they are of same size, so they are equal vectors. Co-linear vectors, but not equal. Okay. A bar and D bar look size is same. They are equal and co-linear. So how they are? I mean, what do you think about it? Think about it. Direction is opposite, right? So they are co-linear but not equal. Even though sizes are same, but they are in opposite direction. They are not equal. Okay. Next. A bar and minus A bar are collinear. Okay, true or false you have to state. Yeah, this is true. They are in opposite direction, but they are collinear. Two collinear vectors are always equal in magnitude. No, need not be. They need not be same magnitude. False. Two vectors having same magnitude are collinear. That's also false. Two collinear vectors having same magnitude are equal. That is also false. Okay. Yeah. Now let's learn about the vector addition. Now we know the basics of the vector. Let's learn the vector addition. Okay. So vector addition stated as, suppose if you have a vector AB, okay, A is the initial point, B is the terminal point, and plus BC, okay, B is starting from the terminal point of A and ending at C. This is the terminal point. Then AB plus BC vector is equal to AC, the initial point of the first vector and the terminal point of the second vector, right side. Okay, so this is the vector addition. Okay, so we state this as AB plus BC equal to AC, or AB plus BC minus AC equal to 0. Minus AC, I can always write it as CA. Okay. So if I write AB plus BC plus CA equal to 0, which is AA bar, right? Same position, coming back to the same position. This is called a triangle law of vector addition. Okay. If you want to check three given positions are in the uh, forms a triangle, then this is one way of checking. Okay. And then this is a parallelogram where A bar, B bar is there, and obviously the opposite sides are uh, collinear vectors, right, of equal size. So you can actually call them equal vectors. Okay. Then A plus B bar is always diagonal. A plus B bar is always diagonal. This is a parallelogram law of the vectors. Okay. AB plus B equal to C bar. C bar is nothing but diagonal. Okay. Now properties of vector addition: A plus A bar plus B bar equal to B bar plus A bar. This is commutative property. This is actually symmetric. Yeah, symmetric property. And then a plus b plus c is equal to a plus b plus c. This is associative. A plus 0 bar, that is null vector, is equal to null vector plus a bar, which is equal to a. So null vector is the additive identity, right? Now, position vectors and vector addition. If P1 and P2 are defined x1, y1, z1 and x2, y2, z2, then P1, P2 vector is nothing but x2 minus x1 I bar, y2 plus y2 minus y1 j bar, and z2 minus z1 k bar. Okay. And what is the magnitude of P1, P2? Square root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Now, let's say A and A is defined as, sorry, A is defined as x1 I y1j plus z1k and b. This is b. Okay. And b bar is defined as x2i plus y2j plus z2k. Then a plus b, a vector plus b vector, vector a plus vector b is equal to x2 plus x1i, y2 plus y1j, z2 plus z1k. This is how we do the vector addition. Okay. Very simple. Then multiplication of a vector by scalar. What happens when you multiply a vector with a scalar? Scalar is just a number, right? Some number. I am multiplying a vector with a 10. Okay. Only thing changes is its magnitude. Means size will either increase or diminish. Right? Size will magnify or diminish or increase or decrease. That's all. And depending on the sign of the scalar, that is if it is I am multiplying with minus 5, let's say, the direction of the vector also gets reversed. Okay. So that's the only change which can happen when you multiply a vector with scalar. Okay. So if a bar is a vector, k is a scalar, ka bar is a vector in same direction or opposite depending on the sign of the k. Ka bar is obviously collinear with a bar. Maybe direction is changed, but they are actually same, parallel. Directions may be different, but so they are collinear. And magnitude of ka bar is nothing but k times a bar. Okay, magnitude of a bar. And one thing you remember, magnitude is always positive number. You have to represent always positively. Okay, no negative. Even though you write square root of x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square, don't put plus or minus in front of magnitude. Magnitude is always positive number. Okay, next. So if you see this multiplication with scalar, what happens is, let's say this is the main vector. Okay, v. When I multiply with 3, it becomes 3 times. Multiply with minus 2, direction is changing and it is twice the size. Multiply with the half, it has become half of initial size. Okay, so this is the effect of multiplying with a scalar. Okay, k times null vector is always null vector. Okay, for any scalar. For any, you take any scalar, if you are multiplying with a null vector, you will always get null vector. Next, components of the vector. Okay, in two-dimensional space, if a line AB vector represented by AB equal to xi plus yj, there is no z, right? There is no k basically because it's a two-dimensional space. Okay, xy are called length of vectors x component and y component. Okay, in three-dimensional space, you will get x component, y component, and z component. Okay, so this is how it is represented. Okay, and similarly, three-dimensional space, of course, you have a line AB represented by xi, yj, zk, and xyz are xyz components respectively. Okay. So this form of any vector is called component form. Okay, if you write in this way, xyz are called scalar components of the vector. Xi, yj plus zk are called vector components of along the three axis. So you take any vector. What is xi? Xi represents the vector in x direction. Yj represents the vector in y direction. K represents k hat or whatever you can call, represents the vector in z direction. Okay. Sometimes x, y, and z also called rectangular components. Okay. Next. Continuation with that. So if a r bar, r vector is defined as xi plus yj plus zk. So whenever I say ijk, please remember I should actually say I hat, j hat, k hat. Okay, they are the unit vectors in the direction of x axis, y axis, and z axis. Okay, they are the unit vector. I, j, k are unit vectors. x, y, z are their magnitudes in the direction of x, y, and z. Okay. So if vector is represented with xi, yj plus zk, then magnitude or length of this vector r is nothing but absolute r, which is equal to x square plus y square plus z square. Okay. And if A is represented as A1i, A2j plus A3k, and B is represented by B1j plus B2j plus B3k, then A1 plus A2, what you will do? You just sum up the x components A1 plus B1, sum the y components B2 plus A2 plus B2, j, there is no y, a, I here, sorry. So many mistakes. And you learn from the mistakes, so don't worry. Okay. And z components will become a3 plus b3. So you basically add the respective x, y, and z components, and that's how you get the resultant vector. Okay. This is how you get the resultant vector. Okay. And if you do minus, obviously same components you will take x component, y component, and z component of the respective vectors and just subtract them. So a1 minus b1, a2 minus b2, a3 minus b3. And you remember, okay, you remember that whatever way you are subtracting the vector a minus b, you subtract the components in the same way. Otherwise, the directions will go wrong. Okay. You cannot say a1 minus b1i and b2 minus a2i. No, that is wrong. Right? Direction is going wrong, right? So that is wrong way. So whatever way you are subtracting, what is the first vector and second vector, the components also you should take in the same way. When you subtract or add, addition doesn't matter, but subtraction, be careful about it. Okay. A vector A and vector B are equal if, that means if and only if A1 equal to B1, A2 equal to B2, and A3 equal to B3. Only then they are equal. And K is the scalar product. If you multiply scalar product with vector A, it means you are multiplying each component, x component, y component, and z component with the same scalar. Okay, like k a1i plus k a2j plus k a3k. Okay. Now, if you have k times vector A plus m times vector A, you can actually write it as k plus m times vector A. K times m times vector A is equal to km vector A. Okay, so all these things are straightforward. Okay, only thing is, yeah, you will get a lot of questions based on this. So remember this. Okay, continuation. This is nothing but your, we learned already the direction ratios or direction cosines, correct? So only thing is, we will understand this very easily once you understood this ijk form, right? Now these are the three unit vectors in the direction of x, y, z of a given vector, correct? So if a vector A is defined as ai plus bj plus ck, the direction ratios are simply the coefficients ABC. Direction ratios are ABC. Direction cosines are, how do you get the cosines? Okay. So let's say alpha, beta, gamma are the three angles in the x, y, z and directions. Then, okay, cos alpha equal to L, cos beta equal to M, cos gamma equal to N. But how, from where you'll get L, M and values? Okay. So cos alpha, which is equal to L, right, equal to AX, that is A. Okay. In this case, it is actually A. Okay. AX, AY and AZ are the three components, right? So AX by magnitude of vector A, cos beta is equal to AY by magnitude of vector A, cos gamma is equal to AZ divided by vector A, magnitude of vector A. So this is how you will get the cosine ratios, direction cosines. Okay, section formula. We know what is section formula. If two vectors A bar and B bar are at an angle and then R bar is dividing the PQ bar, okay, the PQ in a ratio M is to N, okay, then this is represented, R bar is represented by, okay, MB bar plus NA bar divided by M plus N. Okay, this is, you would have learned already in coordinate geometry, right? Same thing, exactly same in the vector notation. So if it is externally division, then MB bar minus NA bar divided by M minus N. Okay, be careful, where is M, where is N, you can check. M is the bigger size here, right? Bigger one is M, smaller one is N. Okay, and midpoint formula is same again, A bar plus B bar by 2. Let's do the exercise 10.2. Okay, compute the magnitude of the following vectors. I think this is a straightforward question. You can do it yourself. This is nothing but square root of, if it is x, y, z are the coefficients of I, j, k, then it is square root of x square plus y square plus z square. Here x, y, z are 1, 1, 1, so it's 1, 1, 1, root 3. Similarly, other things you can do it yourself. And just remember, magnitude should be always shown as positive number. Okay, next. Write two different vectors having same magnitude. Okay, that is very simple. If you have a vector in I, J, K form, okay, then you just switch the coefficients of the I, J, K. Okay, exchange coefficients, then you will get magnitude is same, and signs also you can change. Okay, but it's a different vector. It's not same as previous one, right? So that's what I did here. Next. Write two different vectors having same direction. Okay, so one way is we know, find the direction cosines and then try to make them same. If the same direction cosines are there, then vectors are same, basically same direction, right? So one vector I took here, I plus 2j plus k, its direction cosines are 1 by root 6, 2 by root 6 and 1 by root 6. So we'll try to just take another vector, just multiplication with the scalar. Okay, 2, 4, 2. Then it's again, its magnitude is 2 root 6 and direction cosines are same. So these two vectors are in the same direction but different magnitudes. Okay. So simply what we have done, we have taken vector 1, multiply with a scalar. Okay. Positive scalar, because we don't want to change direction, right? Same direction, positive scalar. Then you will get the other vector, okay, which is in the same direction. So k is a positive scalar here, positive rational number. Next. Find the values of x and y so that vectors are equal. Okay, this is straightforward. You will compare equate the coefficients of x, coefficients of I, coefficients of j. Okay, so x equal to 2, y equal to 3. Next. Find the scalar and vector components of vector with initial point and terminal point. Okay, once you have initial point and terminal point, you can make a vector, right? A bar is equal to minus 5 minus 2 I plus 7 minus 1 j. Okay, so this is my vector. Okay, once I know the vector, what are the scalars here? Minus 7 and 6 are the scalar components. Vector components are minus 7i comma 6j. Sum, it is a straightforward question. You can just sum each term independently. I term, j term and k term independently. You should sum or subtract it. Okay, so this is simple. Find the unit vector in the direction of a vector A. A is given. Okay. How do you find the unit vector? Okay. This is not a unit vector because its magnitude is more than 1. Right? Its magnitude is root 6. So you divide the vector with root 6. Okay. That is basically you're multiplying with 1 by magnitude. Then you get the unit vector. That's what I did here. Okay. Next. Find the unit vector in the direction of vector PQ, where PQ are points given here. Okay. So first thing is, what is your vector? PQ bar is nothing but 4, 5, 6 minus 1, 2, 3, right? So this is my vector 3i, 3j, 3k. Okay. So PQ magnitude of PQ vector is square root of 9 plus 9 plus 9 or 3 root 3. Okay. So unit vector in the direction of this one is I have to divide the vector with the magnitude. That's all. Right. So I'm dividing the vector with the given magnitude. So 3 by root 3, 3 by 3 root 3, I'll get 1 by root 3. Okay. Next. Find the unit vector in the direction of a plus b. So first find out what is a plus b. Sorry, this is b actually. It should be b. Okay. So a plus b is nothing but 2i minus I minus j plus 2k minus k. Okay. That is I plus k. Okay. Once you know this, magnitude we know 2, square root of 2. So unit vector in the direction of a plus b is 1 by root 2 I plus 1 by root 2 k. Find a vector in the direction of vectors which has magnitude 8 units. Okay. So first thing is you find the unit vector of the given vector and then multiply with 8. So you will get magnitude of 8. Correct. So this is the given vector. Its magnitude is the square root of 30. So find the unit vector r bar of unit vector of r. Okay. R hat basically we'll call it, right. So 5 by root 30 I minus 1 by root 30 j plus 2 by root 30 k. Now this is your unit vector. Now we need to increase the magnitude to 8. How do you do? Multiply with 8. That's all. 8 R bar. So this is the required vector. Okay. Show that these vectors are collinear. Okay. So how do you find? One is magnitude you find. Okay. A bar. And then direction cosines. Okay. And the second vector, its magnitude and the direction cosines. If you see the direction cosines are the same, only thing is sign is opposite, exactly opposite. The positive here is negative, negative here is positive. Okay. So which means they are actually collinear but in the opposite direction. Okay. Collinear in the opposite direction. Okay. Find the direction cosines of the vector, which is very simple. You can do it yourself, straightforward question. Find the direction cosines of vector joining 2 points. Okay, directed from A to B. We know what to do. AB bar first we'll find out and then find the direction cosines of this. -2, -4, comma 4. Okay. So simple. Show the vector is equally inclined to axis OX, OY, OZ. Okay, that is x-axis, y-axis and z-axis. Okay, how do you find out this thing? We need to find out the angles, right? Cos or direction cosines basically. Okay. If its direction cosines are equal, then angles are same basically, right? So magnitude is square root of 3. Direction cosines of A bar is 1 by root 3, comma 1 by root 3, comma 1 by root 3, which means this is cos value, right? Cos alpha, cos beta, cos gamma. That means alpha, beta, gamma are same, which means they are inclined, equally inclined to all three axes. Okay, next. Find the position vector of a point R which divides the line joining 2 points PQ whose position vectors are given here respectively in the ratio of 2:1 internally and externally. We already learned this formula. Okay, dividing point dividing. I mean, a position vector dividing the another line in the given ratio, right? So position vector R dividing PQ bar in the ratio m dot m is to n internally is this is the formula. So just apply all the values required values. Okay, m is 2, n is 1, and the q is nothing but this one. P is this one. Okay, so you apply, then this is what you get R bar. If it is externally, this is the formula MQ bar minus NP bar divided by M minus N. Okay, you apply again externally, you'll get externally position vector of R bar dividing PQ externally in M is to N ratio or 2:1 ratio in this case. Okay. Find the position vector of midpoint of the vector joining the points. This one. Okay. Midpoint we know always you just add the respective terms and by 2. That's all right. A plus B by 2 basically. You'll do. So that is Q bar plus B bar by 2. So answer is 3i 2j plus k. Okay, show that the points ABC with position vectors given here respectively form a vertices of a right angle triangle. How do you find a given one is a right angle triangle? First thing is they are vertices, so you find sides, 3 sides. Okay, once you know the magnitude of 3 sides, either you can apply Pythagoras theorem and confirm, or alternatively, which you will learn after this chapter, there is something called scalar product. Okay, if you multiply two vectors with a scalar product, if the value is 0, then they are perpendicular. Okay, x-axis and y-axis scalar product is 0 basically. Okay, so we can try any of the ways. Okay, either you try simple Pythagoras theorem or scalar product. Okay. Okay, two vectors are perpendicular if their scalar product is 0. Okay, how do you find the scalar product? This is AB value, this is BC value, this is CA value. Okay, you try scalar product on any of these two. If any of these two scalar product gives you 0, that means there is 90 degrees between those two vectors. Okay, so if I try here AB bar dot scalar product CA bar, this is what I get. Scalar product, what you will do is coefficients of I you will multiply, okay, plus coefficients of j plus coefficients of k. Sum all the three, you will get a scalar value. Okay, this is scalar product is the results in a scalar value, which is 0 here in this case. So that means AB bar and CA bar perpendicular. Okay, we will learn about scalar product in the after this chapter. Okay, now in a triangle ABC, which of the following are is not true? Okay, so question is not true. AB bar plus BC bar plus CA bar. You check the direction carefully. AB bar BC bar, CA bar. Okay. If it is AC bar, if it is AC bar, it is not 0. Okay. But if it is CA bar is reverse direction, right? You will go back to the same original point, which means it is 0. So this is true. AB bar plus BC bar minus AC bar, which is same actually. Both are same. Okay. A and B are actually same. This is just represented in a negative. AB bar plus BC bar plus AC bar. This is not correct. Okay. AB bar plus BC bar plus AC bar. So it's actually coming here only, right? So this is not 0. So that is false. Other one also you can cross check. AB bar minus CB bar. Okay, that means it goes somewhere here. And CA bar. CA. Okay, CA will go somewhere like this actually. Somewhere like this. So it is not 0. Sorry, it is equal to 0. It will go back to the original point. CA, right? CA. Okay. AB minus CB. Minus CB is nothing but, sorry, BC. Correct? Minus CB is BC. Plus CA. Okay. Plus CA back to A. Sorry. Yeah, this is also true. This is same as A actually. Okay. Plus BC, I am writing it as minus CB. So those two are A and D are same actually. Next. If A and B are two collinear vectors, which of the following are incorrect? Okay. Again, just true or false statements. B equal to KA, B bar equal to KA bar for some scalar K. This is true. We know. A equal to plus or minus B bar, A bar equal to plus or minus B bar. Uh, these two are collinear vectors, right? These two are collinear. So it is false because this is not the only condition for collinearity. Okay. So this is one of the condition, but this is not the only condition. The respective components of A bar and B bar are not proportional. This is false. They are proportional actually. Respective components also are proportional. Both the vectors A and B have same direction but different magnitudes. No. Then the same direction, different magnitudes. Need not be. Okay, right? Collinear does not mean they are same direction. They can be opposite direction also. So this is false. Okay, D is false because they need not be in the same direction. They can be in the opposite direction also. Still they are collinear. Okay. Magnitude of course doesn't matter. Different or same doesn't matter. Okay. Next. Let's learn the scalar or dot product of the vectors. We have seen one example in the previous chapter, previous exercise, right? So let's learn it fully. Scalar or dot product of A bar and B bar, two vectors, is defined as A bar dot B bar. It's called scalar or dot product. That's why is equal to absolute value of A bar, or magnitude of A bar, magnitude of vector B into cos x, where x is the angle between the vectors. Okay. So this is what it is defined. This is what is scalar product. Now either of vector A or vector B is null vector, then angle is defined as, or angle is not defined basically between them. So scalar product will become null. Okay. Just like multiplication, right? The angle between the vectors equal to 0. Okay. If the angle between the vectors is 0, then scalar product of vector A dot vector B is equal to magnitude of A into magnitude of B. Cos 0 is 1, right? So that's why we ignore it. If vectors are perpendicular, then scalar product is 0 because cos 90 is 0. If vectors, if angle is 180 degrees, then scalar product is exactly negative of product of their magnitudes, negative magnitude. Okay, a negative product of magnitudes. Okay, and angle between two vectors, if you want to calculate, the way is scalar product divided by product of their magnitudes. Okay, scalar product is commutative, which means A dot B is equal to B dot A. Okay, so remember all these things. And then also few more properties of scalar product. Distribution law of scalar product, okay, over addition, vector addition. So A dot B plus C is equal to A dot B plus A dot C, just like multiplication over addition. For any scalar product, K A dot B is equal to, you can put the scalar multiplication anywhere. So that is what is this. And this is the most important. This is what we used in the previous exercise. If A vector is defined as A1i 8 plus A2j plus A3k, and B is defined as b1i plus b2j plus b3k, then scalar product. Okay, vector a dot vector b is equal to a1 into b1 plus a2 into b2 plus a3 into b3. Now you understand how we calculated last time. Okay, so remember this. And these graphs are important actually. If you know the angle between the two vectors is acute, less than 90 degrees. Okay, this is how it looks. Okay, and where the resultant vector will be formed, that you will understand from this. And what will be the scalar product? It is positive, negative. You will understand easily. This is positive, right? Because it is less than 90 degrees. If you remember the trigonometry, all silver teacups, you know which quadrant, first quadrant and fourth quadrant, cos value is, cosine value is positive. Rest all it is negative. Okay, other two basically. Okay, okay. Other important formula, Cauchy-Squar's inequality for the vector scalar product. Okay, this is mainly for the vector scalar products. For any two vectors, okay, a and b, we always have magnitude of a bar dot magnitude of b bar, or multiplication basically, is greater than or equal to magnitude of scalar product of those two vectors, a dot b. Okay, so what is the proof? Simple proof. We know that angle between the vectors is, let's say if it is a, cos a is equal to scalar product divided by magnitude of those vectors. This is what. And cos a is less than or equal to 1. We know, right? Cos a is always less than or equal to 1. It is not, it is between -1 to 1, which means if I take a dot b scalar product less than or equal to, okay, product of their magnitudes, right? So this is the simple, very simple inequality proof, okay, which is very useful. Triangular inequality is sum of two vectors is greater than or equal to the magnitude. I mean, sum of magnitude of two vectors is greater than or equal to magnitude of sum of the vectors. Okay. So these are the simple formula based on scalar products. Okay. Let's do exercise 10.3. Yeah, this is very simple, straightforward question. Angle between two vectors with magnitude is given here, and scalar product value also given. So it is very simple, straightforward equation we substitute. Find the angle between two other vectors which is given here. So you find the magnitude first, magnitude of a bar, magnitude of b bar, then scalar product, okay, and then divide by. Again, apply the same formula. Okay, cos x equal to scalar product divided by product of their magnitudes. Okay, find the projection of vector I minus j on the vector I plus j. Okay, so this is simple. Projection of vector A onto vector B is given by scalar product divided by the second vector on which we are projecting. Okay, magnitude of second vector. So if I calculate this, a bar dot b bar is equal to 0. If you clearly see, okay, if you imagine two-dimensional space, then this is let's say 1 comma minus 1, this is 1 comma 1. There are obviously, if you draw a line from origin, they are 90 degrees. If they are 90 degrees, scalar product is 0. Okay, anyway, so this projection is 0. Next, projection of other two vectors. Yeah, now you apply this formula, you will get the answer. Okay, simple. Projection is 60 by square root of 114. You can simplify further. Show that each of the given three vectors is a unit vector. Okay, also show that they are mutually perpendicular to each other. Okay, so this is simple. How do you know if a given vector is unit vector or not? Find the magnitude. So magnitude of all three is actually same. If you take negatives, you can ignore, because in a square, when you do square, sorry, this is not to the power 3, this is square. Okay, okay. So it is 2 square plus 3 square plus 6 square, square root of divided by 7. 1 by 7 is there for all. So which is 7 by 7, you will get 1. So 1 means it's a unit vector. So all three are unit vectors. And then how do you find out they are mutually perpendicular? So you know the cos of the angle between the vectors equal to scalar product divided by product of their magnitudes. So now you have three vectors here. So do it for all the pair of two vectors here. Then you will get the value as 0, which means angle between them is 90 degrees. Cos x equal to 0 you will get, which means x is 90 degrees, means they are perpendicular. Okay. Okay. So next. find magnitude of vector A and magnitude of vector B if a plus b into a minus b equal to 8 and a is magnitude of a equal to 8 times magnitude of b. Okay, so this is simple uh, number theory and equations which you will substitute here, right? So a plus b into a minus b is nothing but a square minus b square, or in this way it is the scalar product. So you will have absolute magnitude square of vector a minus magnitude square of vector b, okay, which is equal to 8. This is your first equation. And second equation is given in the question itself as magnitude of A is equal to 8 times magnitude of B. So if you substitute that, you will solve the equation. You will get both magnitude of B bar and A bar. Okay. Next, evaluate this product. This is again, you just multiply, just like any other polynomial multiplication you do, you multiply it. Okay. Once you know this, A dot A is magnitude of A square, A dot B is remains A dot B. Okay. uh, B dot B is magnitude of B square. So it's like this. So angle is not given, so you cannot find out the value of this one, A dot B. So leave it like that. Find the magnitude of two vectors A and B having the same magnitude and such that the angle between them is 60 degrees and the scalar product is 1 by 2. Okay, so a lot of information is given actually, just put them correctly. Magnitude of A equal to magnitude of B equal to K, A dot B equal to 1 by 2, angle between the vectors is 60 degrees. So simple, cos 60 equal to A dot B by product of their magnitudes, which is K and K, right? So 1 by 2 K square equal to 1 by 2, or K square equal to 1, or K equal to uh, plus or minus 1 you can take. Okay, but since it is a magnitude, you always take positive value. Okay, so magnitude of A and magnitude of B is 1. Find magnitude of x for the given equation, okay, for a unit vector where x minus a into x plus a equal to 12. This is nothing but x square minus a square, right? Vector scalar product. So absolute x square minus absolute, magnitude of a square equal to 12. Okay, and a is unit vector which is given, so which means it is magnitude of x square minus 1 equal to 12. Then you will get the magnitude of x from that. Okay, next. A is given, B is given, C is given, and such that A plus MB is perpendicular to C. Then what is the value of M? So simple, first write A plus MB. Okay, this is A plus MB, and then A plus MB is perpendicular to C vector C. So scalar product is 0. Now you multiply, and each term should be 0. It's not one term, right? The sum of all these terms should be 0. Okay, which means 6 minus 3m plus 2m equal to 0, or m equal to 8. Okay. Next, if magnitude of vector A into B bar plus magnitude of B bar into A bar is perpendicular to the one given there, you have to show it. Okay. This is simple. How do you do perpendicular always? Scalar product should be 0. So just do scalar product of these two. Okay, expand them. Okay, you will get absolute magnitude of vector A square into B bar into B bar plus B bar into A bar into A bar into B bar. So you will see these things gets cancelled and everything you will get 0. Okay, so which means these two are perpendicular. Scalar product is 0 means they are perpendicular. Okay, A bar dot A bar equal to 0 and A bar dot B bar equal to 0. So what you can conclude about vector B? Okay, so when A bar and A bar will be 0, okay, two vectors, same vector is always makes a 0 angle with itself, correct? So scalar, in a scalar product, it is a magnitude, a product of magnitudes into cosine of the angle between them. So angle between them is 0, so cos of 0 is 1. Okay, so it is just a product of their magnitudes. So product of magnitudes equal to 0 means, okay, product of magnitude square is 0, or magnitude square is 0, which means magnitude is 0. Correct. So A is a null vector. If A is null vector, scalar dot product with any other vector is also 0. So A is a null vector and B can be any vector. Okay. A, B, C are unit vectors such that A plus B plus C equal to 0. Find a value of A dot B plus B dot C plus C dot A. Okay. So this is also a simple polynomial or algebra problem basically. Okay, a plus b plus c is given as 0, and we need to find out the given value a dot b plus b dot c plus c dot a. Okay, so let's square it. Okay, a plus b plus c square it. So a plus b plus c into a plus b plus c. If you expand it, what you will get is a dot a plus b dot b plus c dot c plus 2 times a dot b plus b dot c plus c dot a. Okay, a dot a will be since a b c are unit vectors, a dot a will be 1. Okay, because magnitude is 1, so magnitude square is also 1. So 1 plus 1 plus 1, 3. Correct. So a dot b plus b dot c plus c dot a will be minus 3 by 2. Okay, this is the value. Okay, if either vector a equal to 0 or b is 0, then a dot b equal to 0. But the converse need not be true. Justify your answer. Okay, so yeah, this need not be 0 because scalar product is a product of some integers, sum of product of integers, which you may get 0, even though individually they are not zeros, right? So okay, so you take A as only 3i, so it don't have any y component and z component, and B is 5j, 5j hat, it don't have x component and z component. So A dot B will be 0, right? It will be 0 because it don't have corresponding components, right? Coefficient of I you multiply with 0, coefficient of j you will multiply with 0, so you will get 0. But individually they are not 0 vectors. Okay, so this is the example. Okay, if vertices of ABC are given and find the angle ABC. Okay, so draw a triangle, simple actually. Put the vertices. What is BA? And then BA magnitude, BC and BC magnitude. Now we need ABC, so that means angle between BA and BC, correct? Which is nothing but scalar product. So cos ABC equal to BA into BC divided by magnitude of BA and magnitude of BC. So you substitute the values, you will get it. Okay, cos inverse of 10 by square root of 102. Next, show that these 3 points are collinear. Simple, we have done it before. So you again take AB, BC, and if you see here, both you got exactly same values. AB and BC you got same, which means they are collinear, right? Straightforward. Show that these vertices form a right angle triangle. We have solved a problem before, so exactly same way you can do. Or AB plus BC plus CA equal to 0. You can apply this triangle law. Okay, that is also okay. Okay, if vector A is a non-zero vector and magnitude of A and L a non-zero scalar, L is a non-zero scalar, then L times vector A is unit vector if, okay, if L is, how much should be the value of L? L should be 1 by magnitude, correct? Only then 1 by magnitude of A bar. That means other way also possible, correct? So L equal to 1, okay? LA remains same. So L equal to minus 1, LA remains same but opposite direction, correct? So A equal to L, absolute magnitude of L, then LA is multiplied by a scalar product, change in its magnitude, correct? So A equal to 1 by magnitude of L or L basically, LA becomes a unit vector, hence answer is B. Okay. This is very straightforward thing, simple one you can understand from there. Let's learn the vector product or cross product of the vectors. Okay. So vector product of two vectors. Okay. Vector A and vector B is defined as vector A cross vector B is equal to magnitude of A magnitude of B sine theta n hat. Okay. So first part is simple, magnitude part is simple, which is nothing but uh, magnitude of A into magnitude of B multiplied by sine theta. Theta is the angle between the vectors. What is this n hat? Okay, n hat is nothing but the unit vector perpendicular to both vector A and vector B. Okay, and this direction of this unit vector comes, I mean, you can understand easily from the right hand thumb rule. Okay, you would have learnt in 10th class physics already. Right hand thumb rule, how to use it? You have to rotate your fingers of your right hand in such a way that you are moving from X to Y. Okay. So here if you see, they are moving from X to Y. Fingers are moving from X to Y. Okay. From X, they are pointing to Y. Then the thumb is pointing to the perpendicular direction to both of them and upside, right? So this is the direction of the N bar, N hat. Okay. So this is in precisely this is what is vector product. Okay. Now next properties of the vector product. Okay. Vector A cross vector B is a vector. Okay. Unlike a scalar product where you get the finally scalar product, here you get a vector and direction is n hat, which is perpendicular to both A bar and A vector A and vector B. Okay. Vector A cross vector B equal to 0 if both vectors are parallel. That is, angle between them is 0. So sin theta will become, right, sin 0 is 0. So it will become 0. Okay. So vector product of parallel vectors is 0, which means I cross I equal to j cross j equal to k cross k equal to 0. Whereas I cross j you will get k hat I hat, sorry. Okay. K hat, and j cross k you will get I hat, and k cross I you will get j hat. Okay. So remember this one. Now, is it symmetry? Vector product is symmetry? No, it is definitely not, because angle matters a lot. So when you do the cross product of A cross B, which is equal to minus B cross A, because angle will be exactly in the reverse direction. So this is not symmetry. Distribution, yeah, definitely it is distribution. It follows the distribution law. So A cross B plus C equal to A cross B plus A cross C. Okay. Then multiplying with the scalar, yeah, you can multiply it anyway. Okay. In this fashion, anyway you can multiply. Okay. Now, how do you find out the components of vector product? Simple. If vector A is uh, a1i plus a2j plus a3k, and vector B is equal to b1i plus b2j plus b3k, then vector A cross vector B equal to ijk. Okay, this is the determinant, matrix determinant. You write in this format. Okay, ijk. Okay, second row is a1, a2, a3, third row is b1, b2, b3. Okay, you might already learn the matrix determinant. If not, this is the formula here. You take the I multiplied with a2 b3, a2 into b3 minus b2 into A3. Okay, so here that is I. Now, second one is always you have to take minus j. Okay, so minus, okay, A1 into B3. Okay, you remove this column now because you are calculating for j. You leave this column. Okay, and other columns you take minus j into A1 into B3 minus B1 into A3. A1 into B3 minus A3 into B1. Okay, and for second one, you will get a minus, okay, of j hat. Third one is again plus k, right? So a1 into b2 minus b1 into a2, okay, k hat. So this is the formula you will apply to find out the components of the vector product. Okay, so two things which I missed here is one is the area of triangle. How do you find out the area of triangle of vectors? Very simple actually. You can take any two sides, vector form of any two sides. Okay, let's take A and B. A bar and B bar are two sides of a triangle. Then the area of the triangle is half of A cross B. Okay, vector product you have to do. Okay, and area of parallelogram or rectangle or square, you can find it very simple. A bar cross B bar. That's it. Okay. For triangle, it is half. We know that, right? Half a BH you do, right? So in vectors, you can take any two sides and just do cross product and half. The magnitude of that one is the area of the triangle. Okay. So these two I did not mention here. Remember that. Now let's get into the exercises 10.4. Okay. Find A cross B, which is fairly simple. You just put the matrix determinant form and find out the values. And you want the absolute value of basically magnitude of A cross B, right? So which is nothing but 2 root 19. Okay. Find a unit vector perpendicular to each of these vectors, A bar plus B bar and A bar minus B bar. Okay, where A and B are given. So first thing, find out what is A plus B and what is A minus B. Okay, these are the two here. And how do you get the vector which is perpendicular to both of them? It is very simple. Vector product. Okay, if you take vector product of these a plus b and a minus b, you will get the vector perpendicular to both these. Okay, so simple. You do the vector product. Okay, unit vector perpendicular to above one is vector product divided by magnitude, so that you will get the unit vector. Right. So again, find the matrix form, write it in the matrix form, and find the determinant. What you will get is 24 is the this one, a cross b is magnitude of a cross b is 24. So you will get the unit vector 1 by 24, 16i minus 16j minus 8k, which is this value. This is the answer. Okay. Yeah. Next. If a bar unit is a unit vector, makes an angle pi by 3 with I, pi by 4 with j, and an acute angle theta with k hat, then find theta and hence the components of a bar. Okay, so given that a bar is a unit vector, so its magnitude is 1. Okay, now let's assume that this vector is making three angles. Okay, alpha, beta, gamma. Then a bar is equal to cos alpha I hat plus cos beta j hat plus cos theta k hat. Alpha and beta are given. Okay, alpha and beta are given. So if I substitute cos pi by 3 I plus cos pi by 4 plus j plus cos theta k. So which is equal to 1 by 2 I plus 1 by root 2 j plus cos theta k, and its magnitude is 1 because it's a unit vector. A is a unit vector. So you take the magnitude, okay, and equate it to 1. What you will get is cos square theta equal to 1 by 4 or cos theta equal to plus or minus half. Since it's acute angle, right? Theta is the acute angle, theta equal to pi by 3. This is the only angle possible. So with this, if I substitute, the components are, these are the three components. Okay, and this is the vector. Okay, and theta is pi by 3. Next. Show that a minus b cross a plus b equal to 2ab. This is very simple. You just expand it. Okay. A plus b into a minus b into a plus b, you expand it. Okay. Write the order correctly because you are doing cross product. Okay. You are doing cross product. So order matters a lot. A cross a. Okay. Into plus a cross b minus b cross a minus b cross b. Okay. So what I will get is, I can write this as plus a cross b, right? Minus, if I take inside the vector, it will become a cross b. B cross a will become minus a cross b, right? So I can change that. Okay. And a cross a is parallel vectors. So this will be 0. Angle between them is 0. So this value is 0. B cross b also 0. So what I am left with is a cross minus a minus b cross a plus b equal to 2a cross b. 2 times a cross b. This is what I am left. Okay. Now find mu lambda and mu if this cross product is equal to null vector. Okay. So simple, expand it, write the matrix form. Okay, expand it, you will get three terms, right? So unit vector, each term should be 0. Correct? Each term should be 0 means simple one, you take 27 minus 2 mu equal to 0. 2 lambda minus 6 equal to 0. You will get lambda and mu values, right? That's all. Next. Given that a bar dot b bar equal to 0 and a cross a bar cross b bar equal to 0, what can you conclude about the vectors a and b? Okay, so if a bar and b bar is equal to 0, what you can say? It's only that cos theta should be 0, which means theta is equal to 90 degrees. Correct? Theta equal to 90 degrees. Okay, or magnitude of one of these vectors should be 0. This is also possible, right? Any of them, right? And for a cross b equal to 0 means one is sin theta equal to 0. Okay, or either of the vectors is 0. Either of the vectors is null. So which is possible? It cannot, theta cannot be 90 degrees and 0 degrees. Is it possible? That's not possible. So either of these vectors is null vector. Correct? Either of the vectors is a null vector. Okay, next one is A, B, C are three vectors. Then this is given, vectors are given. Show that A cross B plus C equal to A cross B plus A cross C. You have to just simply do a very simple cross product and addition actually. So you can do it yourself. You will get the, you can easily prove this one. Next, if either A bar equal to 0 or B bar equal to 0, then A cross B equal to 0. Is the converse true? Justify your answer. Okay. Uh, this we know already, right? If a cross b equal to 0, okay, either a bar equal to 0 or b bar equal to 0 or theta equal to 0. You have another condition, right? Third condition also there, where if theta equal to 0, then also there will be 0, which means if they are collinear vectors, correct? If they are collinear vectors, then cross product is 0, right? So this is the example. These are collinear vectors I plus j plus k and 2i plus 2j plus 2j plus 2k. These two are collinear vectors. If you take the cross product, you actually get 0 bar. Okay, so this is the example. Converse is not true exactly. Okay, because we have third condition, which is angle between the vectors. Next, find the area of the triangle with vertices. 3 vertices are given. First, find out the vector form of the sides. Okay, so AB bar equal to I plus 2j plus 3k. BC bar equal to minus I plus 2j plus 0k. Now, I told you that area of the triangle you will get is half into AB into BC. Correct? Half into cross product of two sides. So, any two sides, that is okay. So, cross product of any two sides, and then you take the magnitude of it, right? So, magnitude of cross product by 2. So, that I'll get 1 by 2, and matrix form if I write, what I'll get is the square root of 61 by 2. These are the square units. This is the area of the triangle. Okay. Find the area of the parallelogram whose adjacent sides are determined by the vectors, these two vectors. Okay. So, this is straightforward. Just do a cross product, right? Okay, area of parallelogram equal to cross product of the adjacent sides only, not opposite sides. Okay, remember this. Okay, matrix form you write, what the answer you will get is 15 square root of 2 square units. Let vectors AB are such that magnitude of A equal to 3, magnitude of B equal to square root of 2 by 3. Okay, A bar cross B bar is a unit vector, then angle between the vectors is how much? Okay, this is, yeah, simple. You have the A cross B, okay, and which is nothing but absolute A into absolute B. I mean, magnitude of A into magnitude of B into sine theta and n hat, correct? Which implies absolute of uh, magnitude of A cross B is equal to just magnitude of A product with multiplication with magnitude of B into sine theta, right? So, once you know this one, this is very simple. Sine theta equal to this value, which is nothing but 1 by, okay? Because A cross B is a unit vector, which is given, right? So, this is 1. We know it. Okay, you can also do the same with cross product also. Yeah, both are same actually. Okay, so 1 by root 2, which is 45 degrees or 5 by 4. Next, area of the rectangle with position vectors given is how much? Okay, that's a question. So take the position vectors. You need only 3 actually, AB and BC, right? So AB is this value, BC is this value, then area is nothing but cross product of these two. Okay, which is you write in matrix form, then 2 square units. This is the answer. Okay, next. Okay, these are the miscellaneous exercise part. Okay, after the main exercises, they give miscellaneous exercise. Let's do this. Write down a unit vector in XY plane making an angle of 30 degrees with the positive direction x-axis. Okay, you have to write a unit vector in XY plane making an angle of 30 degrees with the positive x-axis, which means if it is making 30 degrees with the positive x-axis, it is making 60 degrees with the y-axis also, correct? So remember that. This is very simple. R bar equal to cos theta I plus sin theta j, okay, where the angle is with the positive x-axis. Therefore, substituting theta equal to 30, what you will get is R equal to cos 30 I plus sin 30 j, okay, equal to square root of 3 by 2 I plus 1 by 2 j, okay. From where I got this equation? You always know that it is cos theta I plus cos alpha I plus cos beta j plus cos gamma k, right? Okay, which is actually same. It is angle made with each uh, axis, right? So instead of sin theta, I can write here as cos alpha, let's say, okay? Cos theta I plus cos alpha j, okay? And what is alpha? Alpha is 60 degrees. Alpha is 60 degrees because if a line is making 30 degrees with the x-axis, then it will make 60 degrees with the y-axis. So My cos alpha is cos 60. Cos 60 is nothing but sin 30 again, right? So that's why I wrote sin 30 here. Okay. Next. Find the scalar component and magnitude of the vector joining the points. This one. Okay. Scalar component and magnitude. Okay. First is P and Q are given. So PQ bar, which is this value. Just you have to mention the scalar components, which are x2 minus x1, y2 minus y1, and z2 minus z1. And magnitude is nothing but square root of x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. Okay. A girl walks 4 kilometers towards west, then she walks 3 kilometers in the direction 30 degrees east of the north and stops. Determine the girl's displacement from the initial point of departure. Simple. You can actually draw a line first. Okay. 0 is where she started. She walked 4 kilometers west. Okay. She came to point A, 4 kilometers. Then she walks 3 kilometers in a direction 30 degrees east of north. Okay. 30 degrees east of north. North. And it is making 30 degrees with north. So this angle is 30 degrees. So this is 60 degrees. With x-axis, it is making 60 degrees now. With y-axis, it is making 30 degrees. And this is 3 kilometers magnitude. Okay. Now you want the uh, position coordinates. Okay. Girls displacement. Sorry. Girls displacement is nothing but OP. Right. OB bar you need. Okay. So AB is 60 degrees with x-axis. So AB bar equal to 3. AB bar equal to 3 times cos 60i plus sin 60j, just like before I used, same way I'm using now. Okay, from the triangle of law of vectors. Okay, OB bar equal to OA bar plus AB bar, so which is nothing but, okay, nothing but here you can see minus 4a minus 4i, because first one is OA is minus 4i, that's it, right? Minus 4i, negative side. From origin it is starting in the west direction, right? So minus I'm taking minus 4i plus this value, which is equal to minus 5 by 2 I plus 3 root 3 by 2 j. This is the answer. Okay. So diagram is very important, and angles you identify is important. Okay. Angles, where is the angles, that is very important. Next. If A bar equal to B bar plus C bar, then is it true that magnitude of A bar equal to magnitude of B bar plus magnitude of C bar? Justify your answer. Okay. So this is, we can easily take some example and do it. Okay. This implies, this one he has given. This is true if all the vectors are collinear, only then. Okay. If they are in angle, then it is not actually. Okay. If the vectors are in the shape of triangle, then, okay, A bar equal to B bar plus C bar. Correct, triangle of vectors. But A bar is always less than B bar plus C bar, means uh, magnitude of one of the side. That magnitude of A bar means one of the side. Length of one of the side is always less than sum of lengths of other two sides. This is triangle property, right? So which means this is not applicable. This is equal, right? In triangle of vectors, A bar equal to B bar plus C bar. But magnitude are not same thing is not applicable to the magnitudes of this, right? So this is the example. Next. Find the value of x for which xi plus j plus k is a unit vector. Okay. So very simple. I plus j plus k is x times xi plus xj plus xk, which is a unit vector. So what is the magnitude of this one? Okay. Square root of x square plus x square plus x square equal to 1, or root 3 x equal to plus or minus 1, or x equal to plus or minus 1 by root 3. For this x value, this is a unit vector. Next. Find a vector of magnitude 5 units and parallel to the resultant of these vectors. We have solved this before, so you can do it yourself. Okay, simple. Okay, next. Okay, A bar is given, B bar is given, C bar is given. Find a unit vector parallel to the vector, this one. Okay, you have to just sum up 2A minus B plus 3C. You sum up the vectors and then you get the resultant vector. Now you need a unit vector of this one. So divided by magnitude, that's all. Simple. Okay, show that the points A, B, C are collinear and find the ratio in which B divides AC. Okay, fine. Okay, AB is position vector of the point B minus position vector of the point A, which is this value 4i plus 2j plus 6k. BC 6i plus 3j plus 9k. AC equal to 10i plus 5j plus 15k. Once you know this one, AB plus BC equal to AC. Okay, you can see, right? AB plus BC equal to AC, right? The three vectors are either collinear or form vertices of a triangle, right? Only these two are possible. Okay, so absolute of AB equal to 2 square root of 14. Magnitude of BC is 3 square root of 14. Magnitude of AC is 5 square root of 14. So if you sum up, actually they are equal, right? So these three vectors are collinear. Otherwise, if they are otherwise, triangle side rule says that sum of two sides is always greater than the third side, correct? But they are equal here, which means they are collinear. They are not triangle. Okay. Now to find the ratio in which B divides AC, you have the let's assume that B divides AC in x is to 1 ratio. Why we need to take x is to 1? Why not m is to n? If you take m is to n, m ratio n, if you take, you will have two variables to solve problem. Here you have one variable and you will get the answer in a rational number. That is nothing but the ratio. Okay. So this is a simple trick. Not only here, actually many places, especially in Olympiad, you have to use this actually. So definitely, I'm sure you will use this trick somewhere. Okay. By section formula, the position vector of the point B is xc x times c bar plus a bar divided by x plus 1. Okay. So here it is 5 0 minus 2 B, right? This is B and C you take. Okay. B is equal to A and C is divided in that x is to 1 ratio. So, okay. So here it is 1137 is C and A. Okay. So you simplified, what you will get is uh, yeah, 11x plus 1 I plus 3x minus 2 j plus 7x minus 8 k. Okay, equating corresponding coefficients, 3x minus 2 equal to, okay, and equate to this one, 5x plus 2. Okay, 3x minus 2, you can equate it to 0. This is very simple actually. I don't know why I wrote 5x plus 5. This is just a 5 0 minus 2 actually. It is just 5 0 minus 2. I think this is a mistake. Okay, you have to equate this to, oh, sorry, I took x plus 1 to the other side. Okay, fine. This is correct actually. Okay. Okay. So x plus 1 you have to take to the other side. If you write properly, actually one more step, if you write, it will be very clear. Okay. X plus 1, I took it to the other side. So it has multiplied with 5 into x plus 1, 0 minus 2 into x plus 1. That's what I did here. And equating, simple one is 0 is there. You equate 3x minus 2 equal to 0, which means x equal to 2 by 3. This is the ratio is 2 is to 3 then. Okay. Hope you understand. Just do it properly yourself. Next. Find a position vector of a point R which divides the line joining two points P and Q whose position vectors are given here externally in the ratio of 1 is to 2. Also show that P is the midpoint of the line segment RQ. So yeah, this is simple. You just put the values properly. Position vector dividing P and Q externally in M is to N ratio is this. This is the formula. Okay. Now you substitute the values. R bar equal to 1 into a minus 3b minus 2 into 2a plus b divided by 1 minus 2, which is equal to 3a minus 5b. Okay. So once you know this one, okay, this is R bar. So midpoint of RQ. Which one is midpoint of RQ? These two, right? You take this value, then it is 2a plus b, which is nothing but R bar. Okay. 3a, 2a plus b. Sorry, this is P, not R. This is P. Okay. P is the midpoint of line segment RQ. Okay. So this is P. Next. Two adjacent sides of a parallelogram are given here. Find the unit vector parallel to its diagonal. Find its area also. Okay, so this is a good question. Area is very simple. You will do just vector product. You will get the area. But how do you find the diagonal? Okay, how do we find the diagonal? From the adjacents. Okay, so given the adjacent sides of a parallelogram, A bar and B bar, this is the two. So diagonals are A minus B and A plus B. Diagonals are A minus B and A plus B are the diagonals. Okay. So the one between A and B is A plus B. Correct? That's a diagonal. This is A minus B. Sorry, A minus B is the diagonal. So this is the A minus B value. Unit vector parallel to A minus B is this value. You just divide with the magnitude. Okay. A plus B is this one, and unit vector parallel to A plus B, sorry, is 3i minus 6j plus 2k divided by 7. Okay. Now area is simple, with vector product you can get it. Okay. So this is how it is. A bar, B bar. Okay. And then you have A minus B, A plus B. This is A minus B, this is A plus B. Okay. Next. Show that the direction cosines of vectors equally inclined to. I think we have saw this problem before. Okay, so let's the DCs of the vectors are cos alpha, cos alpha, and cos alpha. Why we have to take? Because it is equally inclined to all three axes. Okay, so if you take this one, then what you will get is this is a given as a cos square alpha plus cos square alpha plus cos square alpha equal to 1, correct? Because three angles, right? Direction cosine formula. So which means cos alpha is equal to 1 by root 3. Okay. Once you know this 1 by root 3, then DCs of the vectors are one of this, right? Plus or minus here. Okay. So this is the answer. These are the direction cosines of this one. ABC are given. Then question is find a vector D bar which is perpendicular to both A bar and B bar and C dot D equal to 15. Okay, scalar product of C dot D equal to 15. So this is simple. First thing is vector perpendicular to AB can be obtained by vector product. So let this be M D bar, we will call it. Why I am taking M is I need a scalar actually so that I can get the scalar product as 15. Okay. So this is the vector product first, and which is equal to M into matrix from determinant, which is equal to M times 32i minus j minus 14k. Okay, now if I do C dot MD, you can do either way, right? Scalar product I can do either way. So MD dot C is equal to, okay, M times 64 plus 1 minus 56, which is equal to 9M. This is given as 15. So which means M value should be 5 by 3. So if I multiply with 5 by 3, this is what the vector I wanted, okay, which will actually perpendicular to both A bar and B bar. And when it is do a scalar product with the C bar, it will give me 15. Okay, so the required vector is this one. Next. Scalar product of the vector ijk with a unit vector along the sum of vectors, okay, is equal to 1. Find the value of lambda. Okay, this is just to follow the instructions carefully. That's all. Sum of vectors is this one. Unit vector of this one is divided by magnitude. Okay, now you just need a unit vector along the sum of this one and equal to 1, right? The scalar product of the vector with another vector. So you do a scalar product of this one with this, with the calculated one. What you will get is 6 plus lambda divided by square root of 2 plus lambda square plus 40 equal to 1. So you just do a equation, simplify the equations. What you will get is 6 plus lambda whole square equal to 36 plus 12 plus lambda square, and other side is square root will go off 6 plus lambda square plus 40. So if you expand it and simplify, you will get lambda equal to 1. Thank you. Next. ABC are mutually perpendicular vectors of equal magnitude. Show that the vectors A plus B plus C is equal inclined to ABC. Okay. So yeah, this is a simple proof actually. It is given that magnitude of A equal to magnitude of B equal to magnitude of C. Okay, and they are mutually perpendicular, which means A dot B equal to B dot C equal to C dot A equal to 0. Okay. Now A plus B plus C makes an angle of alpha, beta, gamma with three vectors respectively, which means cos alpha equal to A plus B plus C into A, correct? Scalar product by magnitudes, product of magnitudes. Okay, which is nothing but magnitude of A by magnitude of A plus B plus C. Okay, magnitude of A, because if I multiply A with A, I get A square, but A with B and A with C, if I multiply, I'll get, they are mutually perpendicular vectors, right? So they are 0. So you will get on the numerator A square, magnitude of A square, and in the denominator you will have magnitude of A plus B plus C and magnitude of A. Okay, so A gets cancelled and you are left with this one. Similarly, cos beta, cos gamma equal to these values, but we know that magnitude of A equal to B equal to C, that of C, correct? So which means all these ratios are same, which means angles are same. Okay, alpha equal to beta equal to gamma, which means A plus B plus C makes same inclination with all three vectors. Next. Okay, prove this is very simple, and this is the proof is, you have to prove this if this is possible, this equation is possible if and only if A and B are perpendicular and not equal to 0. Okay, so you first expand it, A plus B. So what you will get is A dot A plus B dot B plus A dot B plus B dot A, which is nothing but magnitude of A square, magnitude of B square, plus 2 times magnitude of A B cos theta, right? This is a scalar product of A dot B. Now, above equation becomes this one if 2AB cos theta equal to 0, correct? 2AB cos theta equal to 0, only then this equation is possible, right? So, which means theta cos theta should be 0, correct? Because vector A and vector B are not zeros. So, only option is cos theta has to be 0. This is 0 if they are perpendicular. 90 degrees. Theta is 90 degrees. Okay, next. If theta is the angle between A and B bar, then A bar dot B bar is greater than 0 only when. Okay, only when, because A bar dot B bar is always product of magnitudes which are positive. So, only negative term which can come is cos theta, and here it is positive value. So, cos theta has to be positive. Cos theta is positive in which leg? Correct? Cos theta is positive in 0 to pi by 2. That is first quadrant. Cos theta is positive. From these options, you have only first quadrant. You don't have the third quadrant. If there is a third quadrant, that is also correct answer. Okay, next. Okay, again, similar question. Okay, so right, in this case, it is 2 pi by 3. Theta is 2 pi by 3. Yeah, this is another very similar question. J cross K is I dot I is 0. Correct? I cross K is J dot J is 0. I cross J is K dot K is 0. Sorry, K square. Sorry, you will get I square. Sorry, I'm very sorry. J dot K is I dot I is I dot I is I square basically. So that is 1 only. You will get 1. Similarly, this is minus j you will get here. I into k is I cross product with k is minus j. Okay, k cross product with I is j. I cross product with k is minus j. So you will get I dot I, j dot minus j plus k dot k. This is 1, this is 1, this is minus 1. So you will get 1. Answer is C. Theta is the angle between two vectors a bar and b bar. Then a bar dot b bar equal to a plus b magnitude of a plus b. Then theta is equal to what? Okay. So simple. This is also very simple. A dot b equal to a plus b, right? This is what given. A dot b I can write it as a magnitude of a multiplied with magnitude of b cos theta. Okay, and a plus b. Sorry, this is not plus. This is cross actually. Okay, this is cross. So many mistakes this time. This is cross. Okay, so cross product magnitude is nothing but a magnitude of a into magnitude of b into sin theta. So which means sin theta equal to cos theta. This is possible from these options only at pi by 4. Okay. Okay, so that's the end of the vectors chapter from NCRT book. I have not added the critical questions in this because this already the video has become very lengthy. Okay. Only thing is I will definitely add more videos, critical problems from JEE and other engineering entrance exams I will add. Till then, be good with your basics because this is very useful for your physics. Okay. Thank you.